Welcome to the To Health with That podcast, where we break up big health topics into small bites. I'm your host, naturopathic Dr. Amy Newsel, and this season isn't actually a season because I'm busy working on a book. So, what we will have is a few episodes when there's something important to talk about related to MTHFR that hasn't come up in other seasons. I can't wait to get started. This week, let's talk about the maximum safe dose of methylfolate. Now, of course, we've talked about dosing methylfolate, what matters for you, etc., etc. But interestingly, maximum doses haven't actually been studied. So we'll be working with a lot of information from folic acid. Now, of course, folic acid has its own challenges. We know that. Unmetabolized folic acid is a thing. But we still can't assume that taking high doses of even the best form, right, L5-methyl tetrahydrofolate, for long-term is safe. So let's talk about why. Next week, we'll get into how to figure out your best dose for you as an MTHFR mutant or as a person with compromised methylation who needs to take an active form. So there are many different types of folate. Natural folate that occurs in foods like beans, pulses, dark green leafies, avocados. The synthetic crystalline form called folic acid, which is by far the most well-researched form. Folinic acid, which is also available in a synthetic. It's the form mostly made by yeasts, and it's available as a prescription as well. And L5-methyl tetrahydrofolate, which is actually the active form. So that is the form your body uses. Most of the research is on folic acid. One of the big risks of a too high dose of folic acid is masking vitamin B12 deficiencies and also cognitive decline in the elderly. So folic acid has a tolerable upper intake level as set by the RDA at 1,000 micrograms daily, which many of us are getting far more than that from a combination of supplements and fortified foods. So when we're looking for B12 deficiencies in a clinical setting, what we're looking for is changes to red blood cells. When B12 is deficient, red blood cells get larger, forming something called macrocytic anemia. Of course, there's symptoms that go along with this. Fatigue, sometimes a bit of numbness or tingling. It can be very vague. Usually fatigue is the first sign. But what doctors are actually looking for is that macrocytic anemia. If you have a high dose of folic acid in your system, then those red blood cells might never get big. And so the macrocytic anemia could be missed, even though there's still a B12 deficiency. The folate stops the blood cells from showing the B12 deficiency. Now, this is most especially important in the elderly when absorption of B12 declines and when B12 is highly linked to cognitive decline and cognitive performance. So this is a problem that needs to be taken seriously. And of course, it can be solved by doctors running B12 testing, but they don't always do that, right? Another problem with folic acid is unmetabolized folic acid. So synthetic folic acid must go through an enzyme called dihydrofolate reductase to be converted into the natural reduced form of folate, but the enzyme is both slow and easily saturated. And because of that, unmetabolized folic acid remains in the blood even after a single dose of more than 200 micrograms, which, by the way, you can get from a sandwich. A recent study of pregnant women in Canada showed UMFA, unmetabolized folic acid, was detectable in more than 90% of pregnant women's serum and cord blood samples, and nearly all blood samples from the United States. While the risks of UMFA haven't been fully documented, we do know that it competes with receptor sites for folate and methylfolate, essentially blocking active folate from functioning. We also know that children with higher levels of umpha in their cord blood at birth are at higher risk for autism and spectrum disorders, especially when those children are Black. Umpha is obviously not a problem when you're taking methylfolate, but we should still consider whether or not the methylfolate is building up in any way. And, as I mentioned, this research doesn't exist yet. It has not been done. The biggest and most important thing I feel is cancer. So the relationship between cancer and folate is a complicated one. It's a double-edged sword and likely has more to do with the whole body folate status than with the particular form. So this risk may very well apply to methylfolate as well as it does to folic acid. But again, that has not been verified. Research generally shows that both too little folate and too much folate are a problem with cancer. Too little because the lack of folate causes altered methylation patterns in the genes, right? Thereby allowing cancer promoter genes to express because they're not methylated, they're not turned off, and reducing the effectiveness of cancer suppressor genes. So when methylation is unbalanced, the gene activity is also unbalanced. Too much folate becomes dangerous for a different reason. Too much folate encourages cell growth and division. And if there are cancerous cells present, which there may be, then they grow and divide more quickly. This is why anti-folate medications like methotrexate are such big kind of pillars of cancer treatment. So this is especially important in solid tumors and a folate-rich environment, even if it's the best folate, the active methylfolate, may still have this effect. At the end of the day, my takeaway is that it's not safe to assume that high doses of methylfolate are completely safe. I am always a fan of foods instead of supplements, and supplements only when needed. There's also mixed research about metabolic disease and folate. One study conducted on rats, not humans, fed pregnant dams a normal folate diet or a high folate diet, which had 20 times the amount of folate relative to normal. Now, granted, that's a vastly high folate diet, but still. Their offspring were fed regular food or food plus 10% fructose, which is our sugar from corn or from fruits or whatever. It sounds like the lab rat equivalent of feeding them a couple of extra sodas a day. This study found that the rats whose mothers were on the high folate diet were more likely to have higher blood sugar, more visceral fat, and insulin resistance. So essentially, the study's saying that high maternal folate diet programmed those babies for long-term metabolic dysfunction. That is scary, given the rate of metabolic dysfunction in our societies. Now, do we know if this effect carries through to methylfolate? We absolutely don't. The research is just not there, just like it's not there for folic acid in humans. So take it with a grain of salt. In terms of how much methylfolate is too much, we will get into that next episode. I don't think it's a solid answer. I think we're guessing, and I don't think it's the same for every person. So we're going to set up some parameters to figure out how much methylfolate is too much for you. Talk to you then.